handbook and kind of going through different inspection technologies, different inspection methods. Obviously, there's two major kinds of welds. There's more, but there's two majors that we deal with on a regular basis as welders. Can you guys name them? Name one of them, Sherry, Jacob. Go ahead, Sherry.
The vertical?
Vertical, maybe, but no. That would be 3, right?
Well, 3G and 4G.
G. Go ahead, Jacob.
And then you talk about fillet. Oh, G's for groove.
So groove and fillet, correct. So those are the two major type of welds we're primarily dealing with. There's other type of welds, spot welding and other types of welding, but primarily we're going to be dealing with grooves and fillet. So you have different tools for different things. Have you guys ever seen a set of fillet weld gauges?
Mm-hmm.
You have a set, Shari?
Yeah.
Yeah.
You do have a set? Jacob, you have a set as well?
Yeah.
That's great. That's great. Where do you guys got it on your own, or the school provided that for you?
The school provided it.
That's really good. I didn't know that Doug was doing that. That's really good. So do you guys know how to use them then, correct?
Mm-mm.
Start to know.
Nope.
Jacob? Oh, all right.
No idea.
So that's one of the things we'll go over now. I'll teach you guys how to use them. They typically measure. I want to say 3 things, but we're gonna focus on 2. And those 3. I'm gonna look through the handbook and see. I want to say page 18 and 19. Let's see. I want to say. Yeah, that's good. That's just a good page 18 and 19. Bear with us. The first time we've done anything like this. So as we get into this, yep, keep going. Page 18, Missy. Yep, scroll down a little bit. A bit. Get that diagram there at the bottom. It's right in the middle of the screen. That one. Yep, a little bit more. Bam, that's good. So, all right. So I want to just jump back just as a more detailed introduction to what we're doing and why this is important. And I'm gonna revert to Missy to kind of go over that. Missy, can you give the introduction you and I talked about?
Yeah, sorry, I was trying to unmute myself and hitting the wrong buttons. I seem to be doing pretty good at that today. So basically, when we talked about different ways that we can talk to you guys, since we can't physically be there with you right now and it's killing both of us, the biggest thing that came to both of our mind is inspection. And there's a couple reasons for that. So, why is inspection so important? Well, it's important because you're going to need it in your welding career. As you weld, any job you're on, you're going to need to have a level of understanding for inspection. But then in addition to that, like, I know I've been there and I've talked to you guys multiple times, and I always go into, well, what's after welding? So learning as much as you can right now about inspection and continuing to learn that throughout your welding career is going to help you for your next path. So whether that's going to be if you're going to choose to advance into QA/QC inspections, into becoming a CWI, into NDE inspection, this is the fundamental. So this is going to lay all the groundwork for you to get there. So the more that you understand it, you ask more questions about it, and you just continually learn more about inspection is only going to advance your career in the future. So that's always kind of been why I've pushed a lot of inspection. And that's another reason that Aubrey and I both were really adamant with LTI and LBI when we talked about, improvements that they can make in the program. So adding inspection to the beginning of the course was a big one for us. So that's why, we chose to do inspection as our first kind of online course. And we'll probably elaborate on it more. And I'm sure we'll have other inspection courses as well, while you guys are not in school. But that was pretty much the reason we went with inspection to be the first one.
Thank you, Missy. So just to kind of reiterate that, and did we lose Daquan? No, Daquan, you turned your camera off.
So my phone tripping.
What's that?
So my phone just acting up a little bit.
That's okay, but we can hear you. So just to add to that, Daquan was one of my students early on. Maybe I don't know how long you've been welding now, Daquan.
18, 19, 20, 21, 22, like 6 years.
All right. So when he was 18, he's I taught him how to weld, and basically I taught him basically in the backyard and in a little workshop that we had with a lot of equipment, and I taught them how to basically weld with using SMAW, as well as we did a lot of flux core as well, but primarily that and GTAW, and I taught them how to combo weld. I taught him how to be able to pass that monster coupon test that you're talking about, Shari, in a matter of not knowing anything about welding at all to be able to pass that test in a matter of 8 to 12 weeks. It's pretty tight, very strict when it comes to that. It takes a lot of discipline, almost a military type of discipline in order to develop that quickly to where it's consistent. And he's probably been through that training. I mean, to the point where Daquan, you could tell a story if you want of
All right, I already know what he's gonna say. So there was this one night, me and my brother, the next day we had to go take a test at a nuke plant, which is real unheard of. I was 19, my brother was 18. That's real unheard of. He just did get the chance to take a weld test, and we was like right there. You know what I'm saying? That one last practice push. So Aubrey, you know what I'm saying, him being, we're going to get it done, he gave me and my brother like a whole bunch of 5 hours. I'm talking about 5, 6 of them, made me drink them right there. I was up for 24 hours straight. I'm talking about we welded all through the night up. But it was worth it.
The small 5-hour energies, that's what he's talking about. Go ahead, Daquan. I'm sorry.
But it was worth it, you know what I'm saying? But I was sleep deprived.
So out of the 4 of you guys that went tested from that training, I think all you guys passed except for you and Dre, right?
Yes, sir. We failed by 30 seconds.
By 30
second of porosity.
Yep, they passed visual, and then when they did the guided bend test, I was standing there with the inspector. So they did the guided bend test, and this is not it. Obviously, I'm just giving you guys a visual. It opened up, and it was less than a 30-second. So it opened up, and it was within a tolerance, but it was just a 30-second outside or over the tolerance. And you had
just on one strap.
Yep, just on one of the straps. And so Section 9 is a little more strict when it comes to certain things with acceptance criteria. And so just to give you an idea of his background as well. And then obviously he continued there and he became a really good welder. He's been in the field for a long time. You could kind of talk about your experience a little bit, Daquan, as a welder. They're probably going to hear from you a lot better than they hear from me all the time. But tell us a little about with some of the jobs that I've sent you on, that you've been on without me, and where you are now, and how that works.
So like I said, I've been welding for 6, maybe 7 years. I did a lot of welding everywhere, pretty much. Nuclear plants, a lot of boiler jobs, which Aubrey sent me to. He pretty much sent me to all the boiler jobs I've never been to. We used to do a lot of rig work, in Pennsylvania. I did conveyor work. I don't know if you know about.
These two are actually in Pennsylvania, just so you know. So they understand that a little bit about that, about getting out there and doing the work on the drilling rigs. And that's what he's referred to. We did a lot of, on-call ad hoc work on drilling rigs. So you see those trucks running around with the weld machines on it. That was one of, he had a truck and he was working for me, and we had a shop there. We built a lot of stuff for those rigs. So a lot of stuff outside, running any type of piping, anything like that, all types of stuff that he's done. All right, continue. I'm sorry.
I did, which was most of my career welding is doing tank work. I did a lot of, probably about 3 years straight in tank work, in Texas. Conveyor work too. I don't know if you like UPSs and Amazons. I did that for like 2 years strong. Boiler tube work. I remember Aubrey sent me and my brother doing some buddy welding somewhere in Florida. That was kind of fun. I know how to do NDT and inspection work. That's where I'm trying to make my bridge to as well. I'm getting there. I'm real close. UT, MTPT.
Are you guys following him? Shari, are you guys following Jacob? You guys following what he's talking about when he's saying NDT? And
Yeah, he's talking about visual testing and other forms of inspection, right?
Absolutely. That's
Yep,
what he's
correct.
Yeah. So, and then the last few jobs that you've done for me, for Rig Fab, can you talk a little bit about probably the last three? Starting with
the last couple of jobs I did some inspections for the Tampa airport, which is really big for me and Rig Fab itself. They were making a bridge, which was very, 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 very critical. Very critical welds. They were doing flux core. I forget what the bridge code is more so, but it was I think the whole bridge itself weighed over 2 million pounds.
Mm-hmm.
So that was a big job. After that, I did staffing too as well for this company called Specialty. We staff welders, got them in there. There were 3G tests, got them in there working. And then now in this job I'm doing now.
Mm-hmm. And the job you're doing now is what?
I'm doing inspections for Flanders, an on-site inspector, because you have to have an inspector on site to actually weld. So I'm here doing inspections for them.
So from an inspection standpoint versus a welding standpoint, could you explain to them what your days look like versus welding now? Would you guys be interested in hearing that? Like how he made the leap from welding to inspection, and then what his day looks like now, and then kind of what needs to be, what happens, how do you get from being a welder to being an inspector professionally? So go ahead, Dick.
Well, let's just start. Well, obviously, you know what I'm saying, you can kind of get the gist of what an inspector does. I mean, I do enough, but I don't do not nearly as much as a welder. I sit in my car for probably I work 8-hour days right now, so I probably sit in my car for about six of them, good 6, chilling, watching TV. You know what I'm saying? I'm sorry, let me stop. I be reading my code book in the car.
Yeah, you read your code book on my clock, right?
Read my code book. Nah, but it's really laid back. I mean, it's, you know what I'm saying, it's what I get paid for. You just sitting here, and when they need you, you go in and inspect something. Now to get here, I had to have 5 years of credible welding experience with the CWI sign off. So, which would be Aubrey is my sign off. You know what I'm saying? Because he knows I've been welding for more than 5 years. It's really not just get the experience in the field, which I think is a lot better instead of going to school. I think it's either 5 years or go to school for 2. I think it's way better to be a welder and come into the inspection side because you know a lot more. You know what I'm saying? They teach you a lot in school, but being a welder, I know, like, say, for instance, they're welding galvanized now. And I don't know if you guys ever welded galvanized, but galvanized has a tendency to undercut. And it's not really you can do it. You know what I'm saying? You can't really do a lot about it. Now if you look at it from a welding standpoint, you're gonna know, all right, this is galvanized. You know what I'm saying? No matter how much I cut my temperature down, or it's still gonna be some undercut. But you looking at just an inspection, going and looking at from the book, that's undercut. It gotta go. You know what I'm saying? You gotta fix it no matter what, or I'm gonna keep marking it. So being a welder going into the inspection field, you able to find a better medium.
Yep. So just to kind of drive that point home, from an inspection standpoint, did we lose somebody? From an inspection standpoint, the best inspectors were welders previously. So that's a career path that I encourage you guys to really learn a lot about and get on. Did somebody just join, Missy? No? Okay. So just to kind of, go over that. So from an inspection standpoint, when you go on a job as an inspector, from a CWI standpoint or any type of oversight or inspection, you got to inspect two-way criteria. You can't just inspect with your heart, or this is what I know, a rule of thumb. It needs to be to a code, and it needs to be to an acceptance criteria. So it's measurable. It's not, oh, well, I don't know, or it's not, or you'll see me joke on my Facebook talking about calibrated fingernail. Those inspectors come and they'll rub their fingernail or something. Oh, I don't like it because it's cut undercut. You seal that with the fingernail? Like, no, dude, I'm sorry. I know your fingernail's not calibrated. That's not measurable. You're not measuring anything. You're blowing shit at me, dude. That's not gonna work. So and the goal is to empower you guys at this stage in your welding career, beginning stages, with this knowledge, so you don't have an inspector that's going to bullshit you. That's something that's like with Daquan and his group that I trained, along with a lot of others that I trained. I generally teach inspection first. This way, it's not, hey, does this weld look good? Get your gauges. Tell me if that weld looks good. Tell me what's wrong with it. Tell me we're in the code it doesn't meet. We'll have experts out of the code that are copied, and you guys will have a small copy of those going around. So let's talk about how, if it doesn't meet code or does it not. What code are we using? We're using, Section 9, or we're using D11, we're using D16, we're using D15. What code are we using, and what's the accepted criteria within that code? And because that's with oath. Nothing more, nothing less. Obviously, you want to make it more because you want to deliver higher quality, but you can't deliver the quality if you don't know what it is. So I feel that it's almost imperative as a welder for you guys to learn as much as you can, even from a continuous standpoint, about inspection. So that's kind of my take on it. It's not hard to make that leap if you're committed. And just as much as the industry needs welders, the industry needs people to look at those welds to make sure they're right and make sure that they have integrity, and make sure that it does meet the code. So Missy, if you could, while we're talking, if you can queue up the D11 2015, page 209, and let's go. If you could jump straight to page 209, and then we'll go over that. It sounds like somebody's in and out the call. Let me see.
That was me, Aubrey. I just got here.
Hey, brother, how you doing, man? So we're just going over the inspection versus inspectors, experienced inspectors in the field, as you know. And I want you to introduce yourself. We have two students from our Pennsylvania schools, and we didn't have any students join from your school, but we'll catch them tomorrow or whenever we do the next one. But
okay,
we're talking about this inspectors period. Daquan's on the line. He's actually using it says Tia on there, but it's really Daquan. He's actually out of job now and doing some oversight inspection for me. But the inspectors you run into in the field, the ones that don't have any welding experience, tend to kind of bullshit their way along. They don't know what they're looking at. They know the code, but they really can't tell. They don't understand what it takes to create that weld. And we're talking about, you know, Daquan brought that up. I was talking about the good inspectors are the ones that have a strong welding background. And then we're going into the acceptance criteria, and we're going to look at D11. That's what Missy's pulling out, the D11 acceptance criteria. And this is table 6.1 if you guys want to take a note. Shari or Jacob. Table 6.1. And then we'll go over the clauses and that kind of stuff. And it's page 209, Missy. You're not finding it? No. Look at the bottom. I'm sorry. Look at the bottom of the page number on the screen. That's page 167. No. I have to ask you. There it is. So if you could just zoom into that thing and kind of make it bigger and then kind of at the top, and we'll go from there. And then we're gonna go over this big old scary code book too. I don't want it to be to where it's so intimidating. You guys don't want to be bothered with it. And we're gonna start making you familiar with it because you're training to be professional welders. In order to be professional welders, you have to deliver the code book. That's it. Your job is to deliver whatever this thing says. Nothing more, nothing less. If it's more, that's great. That'll be what's called specifications. If it's less, it doesn't meet code. It doesn't get delivered. So this is 2015 D11. There is a new D11 out. It's 2020. We do have a copy of that that we don't mind sneaking and sharing with you guys, especially with your instructors. So Tom, if you want a copy of the 2000, you have it, the 2015, don't you, Tommy?
Yes, sir. Yes, sir. I sure do.
Okay. If you want a copy, if you and Miss Mercer want a copy of the 2020, let me know, and Missy will get one to you guys here probably in the coming week.
Please do. Please do. Thank you.
Yes, sir. You're welcome. So the first thing is probably the most important thing that's on this list. And I know I'm kind of jumping all over the place because we started hearing talk about fillet welds and groove welds. But I want to just kind of go through this acceptance criteria and talk a little bit about it. So let's talk about, let's say, table 6.1. And just that alone means something to me as far as this code book is concerned. So you have what's called tables and you have what's called figures. Missy, scroll 20 pages in the future there from where you are, or just whatever. You'll get to the group of, that's 252 in your thing. So you see these tables, table. You guys seeing that? Keep going, Missy. Figures. Keep going. It's all figures. Figures. Can't see the name of them there at the top. These are all figures. Keep going. And you might have to scroll down or scroll because we're just seeing the top of the pages now. Every one of these is considered figures. So figure 6.3. Scroll down. Missy. There you go. Well, I don't know if we can see it that small. We can't see it that small.
What did you want me to look for?
I wanted to see where it says figures.
Yeah.
Zoom back in.
There's a delay, so I'm trying to do it really slow.
No, that's good. And then scroll to the next page. There you go. And you can move kind of quick a little bit. Right there, figure 6.6. So the reason why I said that, you can go back to table 6.1. I think it's on your 252 on your thing there. All right. So when in the code book, there's several clauses, and they've added new clauses to the new code book. So the information I'm gonna give you about the code book is gonna be I won't say a little outdated, but it's a little bit. But it'll help you understand it. They're divided into your clause and your general parts of your clause. Then at the end of that clause, which is clause 6, and that's why it says table 6.1. You want to scroll back to the top, Missy? Right there, and you zoom in just a little bit so we can read it really easy. That's good. Yep, that's good. At the beginning at the end of that clause, or towards the end of the clause, the index you would call it of that clause or chapter, is what I'm referring to as clause, is the tables. So all the tables and it refers back and forth from the tables into what's an actual written in the clause. And these are all the tables basically describing and going over what's what. After the tables are all done, then it gets into your figures. So if something says 6.1, that could be figure 6.1 or table 6.1. You need to know that so you know what you're looking at. If that makes sense. Or it could be clause 6.1. You know, if you scroll back, which we won't right now, it's too confusing. But if you scroll back, there's a clause 6.1 as well. So it's real easy to get confused if you're trying to navigate through this thing. Daquan, you gotta go do inspection.
I just gotta make a quick round real quick and see what's going on.
So just can you turn your camera around? You know how to, or you just have to hold it around? There you go. So while Daquan is walking through there, he's gonna probably interrupt me while I'm talking about this, so they can kind of see, the inside of that shop. It's not anything extensive. The shop's not even equipped or outfitted just yet. It's something that they're just getting ready to start doing. And Daquan, you might want to turn the volume down so not everybody here in that shop here he's rattling my mouth.
I got my AirPods.
Oh, your AirPods? Okay, good.
Somebody else just joined the meeting as well.
Okay, great.
This is what I'm looking at right here. This is what I'm inspecting. This is just kind of like the skeleton for. Let me walk over here. This is just more pieces. All this is just one piece. All these pieces. It's all just one piece. All the welders over there not doing shit. But this is the final the almost final product right here. It's like a coal mining slag. I personally never saw one. Aubrey could probably tell you more about what it's used for.
Yes, look to the phosphate mines down in southern Florida. And
this is just
this particular client is it's basically an electrical client. They built these big electric boxes, and they needed these skids that go down in the phosphate mines for these boxes to go on. So what's that?
I'm gonna show you guys what I did today. Out of these whole 8 hours that I did today, this is what I inspected today, right here.
Daquan, you should not be saying that on the phone. Just say it.
Well, he's telling the truth. I mean, there's jobs I send him to where he just sits around most of the day, and that's the good life of inspection. But inspection is more about knowledge base than it is about physical work. See y'all later. All right. Okay.
But now I could give him more work to do. So.
Yeah, he could definitely do a lot more work.
Yeah, I think he definitely just signed up for manual labor.
I just got done doing all that. You know what I'm saying?
Who's that? Who's talking? Oh man. Okay, so all right, so just go back what they call it. I don't know if you still hear me or not. So at the very top of this page, Clause 6 inspections. We'll get into what that means. What are they doing, dude? What is that? They playing?
Some of the guys, they're trying to get him practiced up so they can get him certified. He has a long way to go. Yeah,
he does. You gonna test him?
Oh.
So Daquan does a lot of testing right on site. I send him all over the place to test for me. So this can continue on this piece of paper that Missy's got up on in front of us. Right there to the right top page. Oh, sorry. Go ahead. Go ahead. Oh, he muted. He's talking to one of the welders there. Up to the top, to right there, AWFT 101. You guys see that? If you want to cover your mouth over what I'm talking about. Somebody might have to mute it. I don't know.
I think it's his earpiece.
Daquan. Quan. Oh, somebody else. All right. I don't know if you guys can hear me over here or not. Right there, AWS-D11. I'm talking to a welder right now about. Maybe it's my phone. Can you guys hear me? Okay, good. And maybe it's my phone. Oh, we good. It's Daquan. You had to mute Daquan. You're good. What's that? All right. Can you guys hear me still good? All right. So to the top right of this page here, you guys see where it says AWSD right there. AWSD11/D11 D11M 2015. You guys did anybody have any guesses what that means? Sorry.
It's the 2015 version. But I don't know what the M is.
Yeah, what's the M mean?
Hmm.
I know you don't know, you can guess. It means metric.
Oh, okay.
So this is in standard, which they don't indicate. AWS 2000, AWS D1.1/D1.1M means metric. So this book is actually in standard and in metric. So scroll it is down just a little bit. Table 6.1, as we see. Visual, right there, Missy. Right there. Don't go for it. Go back up a little bit. Visual inspection acceptance criteria, and it says C 6.9. Now there's no figure, there's no table. 6.9 is going to be in the clause. All right. So if we were to go back to 6.9, we can read it, and it'll just say here, read this thing. So discontinuity categories and inspection criteria. Statically loaded. You see that so I'm talking about the two columns on the right now. Statically loaded non-tubular connection. Cyclically loaded non-tubular connection. Okay. Do you guys know the difference between statically loaded and cyclically loaded? No?
No.
Okay. Yeah, say no. Okay. So statically loaded is going to be a structure that you compile stuff on. So if I have this, you guys can see this. Well, actually, I got a whiteboard. How about that? I should just use it. If I have this, and I weld this to that, oops, don't fall. I weld this to that, weld this on top of that, weld this on top of that, that's statically loaded. I load all those back down to my base. Make sense? Yeah.
Mm-hmm.
Cyclically loaded is if, like a bridge, if I have this and I'm welding it here, and then load goes on it. So cyclically means cycles. Is the root of that is cyclically. Cycle. Static means still or steady or doesn't change. So cyclically means it's a cycle load. So imagine a bridge or truck goes over it. So it's loaded and then it's not. Something driving over this, it's loaded and then it's not. It's loaded and then it's not. So it's the load, the force, the gravity, the load on it cycles. So cyclically loaded. Make sense?
Mm-hmm.
Think if that makes sense to you as well. So I just want to make sure you guys understand it. Yep. So that's the difference. So you see those words like that? Don't let them confuse you or anything like that. You know, always send me a text message, email, inbox, something. Say, what the hell does this mean? And I'm like, oh, okay, that's pretty simple. I'll explain it. There's different criteria for whether it's a cyclically loaded member or a statically loaded member. There's different criteria for that. Some of them are the same, some of them are different. So number one, and it's what this whole code book is written for and about, is crack. Any crack, regardless of size, location, doesn't matter. It's 100% unacceptable. Period. This code is designed to mitigate cracks. Period. This whole book. That's its job. is to mitigate cracks and welds. In the story. That's it. All these other discontinuities that follow that are just to limit the ability for something to crack. So we're getting to the next one. Weld/base metal fusion. That's so lack of fusion, unacceptable at any point. It doesn't say there's a number or this much is tolerated. No lack of fusion. Next one, craters and cross sections. The crater cross section. Do you guys have any idea what that is?
Just would that be more lack of fusion?
No. So the crater. So number 3, crater cross section is, and I wish I got pictures, but I don't want to keep jumping around. Let's see can you go to page. We have crater cross section in our handbook.
Oh, is it like blowout?
No, it's going to be probably the best example I could see that's in a photo, Missy, is page 16 in the handbook. Oh, Daquan's about to weld. Oh my goodness. Daquan, you're not supposed to weld when you're inspecting on these jobs. I know you want to teach everybody.
I'm not welding. I'm not.
I see you putting on the jacket, dude. You're not just putting that on. I know you're bored. You can't weld for these guys.
I'm not
Go
welding.
ahead. You go. It's not that serious. Go ahead. You can
Did
weld.
you say page 16, page 16?
16 in the handbook. Right there. All right. This is talking about overlap, but so the crater cross section is when that welds in and there's a divot.
Mm-hmm.
You terminate the weld, which means you stop the weld. There's a divot. Well, sometimes those divots get a little excessive, especially if you do a multipass and you stop. If you're doing a multipass, it takes 6, like this, for instance. It takes 1, 2, 3, 4, 5 layers, and you stop at the same spot every time with each layer. Guess what you're gonna have? You're gonna be underfill, or you're gonna have a big old divot there. You're gonna have the crater in that cross section. So that has to be filled back. Okay, and it's here in the code. It says it has to be filled back. You can jump back to the code. Well profiles. There's a bunch of different profiles, and it talks about that at 5.3, and then 5.3 refer to another figure that's back here, and we'll go over that at a more detailed time. Time of inspection. You know what? That makes a difference. You want to scroll up this a little bit, Missy. I got those numbers and stuff. There you go. Time of inspection. Certain rods, certain types of material, they're very prone for what's called underbeat cracking, hydrogen cracking, underbeat cracking. So when they're hot, when they're first made, you don't see failure in them very quickly. Generally, if they cool down to ambient, or if they cool too quickly, you guys go over to your tub and you quench the weld after you get done with it, so you can keep welding. Oh man, they want this, man. And you quench the weld after you get done with it, then that promotes quenching and underbeat cracking. That's why you have a certain time with certain types of steel and alloys, certain types of rod, and it specifies exactly what those are here before you can visually inspect it. And here it says not less than 48 hours on this particular type of material rod. The next one, which is a very important one, and this is the reason why I went here. You want to scroll up this a little bit, Missy. So your fillet welds, and we're gonna stop on these next two. So your fillet welds, once you measure them, and that's what we're gonna talk about, how to use the scope gauge, they have to meet the measurement or whatever it is on the drawing package. However, there's something called underrun or undersized welds. There is an acceptance criteria, which is very clear here, if you guys can see that, what it is. So it says the size of the fillet weld and any continuous weld may be less than the specified nominal size, meaning if they call for a 1/4 inch, it could be smaller than that. Without correction, you don't have to fix it by the following amounts. So if you have a 1/4 inch weld, which is right there in the middle, Missy. You see that? All right. What is the 6 next to that 1/4-inch weld? Anybody have any guesses? Jacob? John? But what's the
Meters.
6? It is millimeters, right? It's millimeters, and it says it up at the top of the title there, not the very top, but right there, which says specified nominal weld size, and it has it in inches, and it has millimeters in brackets. So when they ask questions on the CWI test, once you guys get to that, or you actually in the field doing inspections, you want to be familiar with these documents and how they read, so you can provide your information very quickly. This information is not necessarily designed to be meant to memory. You'll be like, oh, I know where to find that answer. But to have these things memorized, absolutely not. After you get my age and you've been looking at them for years, you'll start memorizing some of them. But they're not really designed to be memorized. Daquan, you want to go ahead and do something? Waiting for me?
No, you good. I'm just
Okay,
kind
go
of
ahead.
helping him with his temperature and all that. He's still a little green.
All right, cool beans. All right, so the underrun or the undersize allowance for 1/4-inch weld is what? What'd you say?
332.
What is it, 332?
Right. Correct. So less than or equal to a 32nd. So that means what side could the weld be? If it's, all right, so you got a 1/4-inch weld, and I go to measure it, and it's not 1/4-inch, what size can that weld be? Still be accepted? Come on.
A 16th?
If it's 3/32, correct. No, not correct, but if it's 3/32 less than a 1/4-inch,
So it's 1/32.
correct. It could actually be really, really super small. It still be. Make sense? That's like an enormous amount. So that's almost basic. They're almost half the size of the weld. That it can still and it still be a good weld. And you read the bottom. In all cases, the underside portion of the weld shall not exceed 10% of the weld length. Meaning, I got a weld that's 20 inches. 10% of that is 2 inches. And this is saying the underside portion shall not exceed 2 inches of those 20, 10%. You understand what I mean? So the entire weld can't be that small. 10% can be, but the rest of it needs to be at the size specified by the drawings. Make sense? Everybody catching that? So so the difference, and that's the other thing I want to make sure I make clear. So at the point where this discontinuity of an undersized weld, say I have a 20-inch weld and an inch of it is small or undersized to this effect, is that a failed weld or that's an acceptable weld? I think she said acceptable. You're muted. She said acceptable. Okay, she's right. So that's an acceptable weld. However, what do we call that 1 inch? There's something wrong with it, right? What's it called? Scroll up just a little bit, Missy. Up, down, scroll down. Stop right there. What do we call it? A discontinuity. So there's a difference between a weld discontinuity and a defect. Oh, we lost. Hey, Kelly's on. Hey, Kelly. There's a difference between a weld discontinuity and a defect. So discontinuity is just something wrong with it, right? Just something wrong with it. Doesn't necessarily mean that it's a defective weld. That just means there's a discontinuity. Certain amount of discontinuities or certain size discontinuity or whatever it might be is that's a defect, meaning a failed weld. All right, so scroll back to our undersized welds, and I think there was one right underneath it that I wanted to talk about was an undercut. It is. So undercut has a criteria as well, and I want you guys to see that, and then scroll down just a little bit more. I want them to see undercut, and there's porosity, and there's different types of porosity, and you'll see how these check boxes off to the right. Some of them are checked, some of them are not, depending on whether cyclically loaded or statically loaded. So probably what we want to do, Missy, if we can, if we can get if you can get a good screenshot of this page at the end of this and email it to whoever's on the call today, so they have it and they can start looking at this and it starts making more and more sense.
Yep.
Would that be useful?
Mm-hmm.
Okay, good.
Yeah, that'd be
So,
real useful.
Missy, if you want to go back to the handbook. And we're going to go to page 18.
Can you try that with your phone?
Yeah, I can do that. So, let me try that. How's that? That good? You're going to hold it high. All the good stuff. You guys see that? Yes? Okay. So, Kelly, what's the most common fillet weld gauge? What's the first fillet weld gauge that comes missing from a pile? Kelly's an experienced welder, so I know she knows this because I'm sure they've used fillet weld gauges where she's worked at. Generally, your 3/8 and your 1/4 inch are the most commonly used, and they come up missing faster out of your group of fillet weld gauges. So, I don't know if you guys can see this fillet weld gauge or not. I'm gonna try to get the glare off of it. It's upside down, isn't it? Yeah, it is. I'm gonna hold it here, see if you guys can read that. Let me know when you can read it. Can you read it? There you go. How about that?
Mm-hmm.
Which one are you using?
All right, so that's a 1/4 inch fillet weld gauge. So there's a few things about this gauge that you need to know. And it's gonna measure two things. Missy, can you scroll your screen back to that diagram that's at the bottom? So your leg size and your throat size. So your leg size, they measures from the center of your weld to where the toe of your weld ties into the base metal. The toe of your weld is that point where your weld meets the base metal. So you have that size, so which is your leg size, and then you have your throat size, which is the middle of the weld itself. Okay, and Shari, you familiar with that portion of the anatomy of a fillet weld? Okay, great. So the gauge is designed to measure both. This gauge.
Mm-hmm.
So we're going to check if this weld meets a 1/4 inch or not. So you have at this point of any gauge at the end of it to this point here. But we're going to be measuring and see if this point touches the weld. And I'll show you. You have to measure when you measure a fillet weld. Sorry for the camera, guys. I'm working on this. When you measure a fillet weld, you have to measure it two ways. And this is way smaller than a 1/4 inch. See that?
Mm-hmm.
So coming from this direction, the vertical direction, coming down, it's smaller than a 1/4 inch. And then you also have to measure it this way, which is smaller than a 1/4 inch there as well.
Yeah.
1/4 inch, right? No, I'm sorry. This is 5/8. I'm like, man, that's awful big. That 1/4 inch gauge is probably gone. That's what I thought about it. Those are the most common ones that are gone. Oh, here it is. All right, here we go. All right. So this weld actually is bigger than a quarter inch because it hits right in the middle of it. You guys see that?
Mm-hmm.
That comes from the top. And then when you measure it, you also have to measure from the bottom as well, too. And it hits right in the middle.
Okay.
Okay? And then on the other side, and that's what I was talking about, if this weld was concave, we would have to double check to make sure that it fills that. And that middle notch there and that gauge is to check the throat of the weld, the theoretical throat of the weld.
Mm-hmm.
And that's what that is. It's a basic go, no go gauge with these. Very simple to use. It's just the key is measure it from the top as well as the bottom, both sides. And if it meets, then it's good to go. Okay? Make sense?
Yeah.
Now you know how to use the weld gauge. The last thing Missy, you could jump in here. It's a VWAC, and we'll get into that a little bit. This is used to measure undercut. It has a series of numbers on it. On the one side, I don't know if you guys can make those out or not. Can you guys see those little numbers? They're small. I'm so sorry. They're really small. We'll get pictures of this stuff and put it up for you.
I can't really see the
down.
numbers, but I can see the whole.
Who's that?
Jacob.
You jumped. Oh, okay. You lost. You had the middle spot.
Yeah, my phone wasn't like connecting right, so I had to like download it on my computer.
Oh, good deal, man. Well, welcome back. So we'll get something like this. This is primarily what Missy and I carry. We carry a VWAC and a steel rule, and we can measure the fillet weld with this. We can measure your groove weld with this. We measure undercut. We measure porosity. This is just a great little tool
And a flashlight.
to have. That and flashlight's imperative. Yep, you need a flashlight. So just real quick, I want to go over this thing with you guys, and then I'll let you go. I know I'm giving you a bunch of information, kind of all over the place, but I love it. So, all right, this beautiful, beautiful, beautiful thing. Let's see if you can help me with this. To go to your code book. This is the 2015.
I have the 2021 as well, but
Yep, and that's go ahead. Go to your 2020. So these code books, just give you an idea with AWS D11, this is the basis of all code books. I don't care what it is. ASME, API, this is D11 is the basis of all code books. All those code books refer at some point back to D11. All of them. Just so you know. So these code books come out every 5 years. Now they'll do like this one is a second edition, I should say. So second edition, March 2016, and Missy will be able to pull that up when she does pull her code book back, or 2015 back. If you want to jump to the home page, first page year, 2015. Probably best to grab that box and go all the way to the top.
yeah.
Okay, and then you can reduce the size a little bit. So this came out in March 2016, second edition. Meaning they made some changes and decided, okay, let's necessary changes and decide, okay, let's re-release this thing. These books come out every 5 years. There's a new one. So there's 2005, there's 2010, there's 2015, and now there's a 2020. The 2020 will probably go into full effect as it's released. So it'll probably go into, I'm not sure exactly what month it's going to go into effect, but I want to say it's here coming in here real soon in April. So when they say the latest on the drawing package, I can find one. Oh, Missy, you got any drawing packages there in the background you can pull up? I don't care where they're from. Suncoke. You don't have to reduce that. You can. Oh, you only got one screen right now? Oh, she got lots of drawing packages. I've seen all of those.
Quit looking.
So on the drawing package, sometimes it'll say use the latest edition of, and I hate when it drives me nuts when the engineers do that. Use the latest edition of AWS D11. Well, guess what? That design may have been created back in 1996. Well, the latest edition was 1995. Well, how many changes have they made to the code book since then? So they say latest edition, and they're building a new one to replace the old one that was designed back in 1996. Well, a lot of the stuff doesn't apply. So much has changed when it comes to certain welds, certain criteria that's being acceptable. It just doesn't apply. So that drives me crazy. I always tell the engineers, no, pick a year and stick with it. Because that's fine, because they say all drawing specs need to meet, at a minimum, AWS 1995 criteria or 2000 criteria. Did we know, okay, I'll get an old AWS book, and everything that has to do with this drawing will reflect back to that 2000 code book. So Missy's trying to pull some drawings. No, those are layouts. Those are not necessarily drawings. Those are the layouts of when we did the SDA. There you go. There's a drawing. You got the rotated.
It's part of the data pack. I don't know if I can.
All right, I'll send you one, and we'll get some together to send them so they can look at some drawings and see. These are with the SBA a little bit complicated. Can you zoom in on that one a little bit? That one, that detail that's in the bottom right corner. You might have to click the hand, and there you go. So I know it's kind of sideways, guys, but this is kind of showing the 1/4-inch square butt groove. This weld was done in the field. That's what the little flag means and the weld symbol. This is still a CJP, which means complete joint penetration. And I'm referring to the weld symbols that are at the top there. Don't move it though, Missy. And it's saying basically it's a 1/4-inch fill and a 1/4-inch reinforced mat. As you guys can see that. And then that weld is performed in the field. That's what the little flag means. And then at the bottom there, Missy, you can scroll up. This is a hair where it says 3/16 fillet weld. So that's a fillet weld. So you got a groove weld, which is a PJP, and you got a fillet weld there. And this is an intermittent weld. So a stitch weld is the lay term of it, but intermittent weld. So that's 2-on-8. Can anybody tell me what that means?
Isn't that a 2-inch weld and then an 8 inches center to center?
Center to center. Very good. Very good. Who taught you that?
Bobby.
Very good. Kudos to Bobby. Center to center. The mistake I see so often in the field, and I have to reject these welds or make it long because it's a minimum criteria. So if that weld's 3 inches long, I'm not going to reject it. However, that's a 2-inch weld on 8-inch centers. So you pull the tape, 8 inches, and then that weld should be in the center of that 8 inches, not 8 inches in between the two. All right, that's like very, very common mistake, and good God, I've gotten some arguments with superintendents and informants over that. Dude, I'm sorry, you got to make that right. That's what it says. It says 2-inch on 8-inch centers. You got 8 inches in between the welds. You missed the mark. So the welds you have to weld twice as much. So the welds need to be 4 inches long to make this right. And sometimes they're like, oh, thanks, Aubrey, good catch. Sometimes I'm like, oh, this asshole. Well, sorry, dude, it's right there, plain English. So these are things that we're getting a little bit more detailed in. And I have tons. When I say tons of real world drawings, the projects that I've done or I've sent him on or other people or other inspectors at right now that we can share with you in this type of forum, because it doesn't violate anything. So just getting back to the code book, Missy, if you want to jump to the 2015. And I'm gonna take about 15 more minutes. You guys got about 15 more minutes for this?
Yeah.
Sorry, you good? You good? Okay. Kelly, you good? I haven't heard from you yet. I know you're there though. I see you, Kelly.
Yeah, I'm good.
All right. So this code book makes sense though. It looks big old, intimidating. It's a big old code book. Nobody wants to open the thing. But it's very simple. Hey, Quan, you got to mute. You got to mute. Thank you. So this is simplified as code book. So imagine, go to clause 1, Missy. This is going to be at the bottom. The bottom is going to be page 1 at the bottom, but you have to go through probably page 16 or 20 or whatever. I don't know if you can find it. So the simplified as code book. Imagine if you were going to build something in your backyard. All right, let's say we're going to build a tank. We're going to build this storage tank in the backyard. And we're trying to decide, okay, what we're going to do with this tank. We need a tank for what? For water or whatever. So we know, okay, we're going to build this tank and it's going to hold water. You can zoom in. So we need to decide what we're going to build this tank out of. We're going to build out of plastic. It's going to be built out of wood. Be a bit out of steel. What? Be out of glass. What are we going to build this tank out of? So that gets into what I call the general requirement. So this whole, what I'm talking about is all about this. Imagine this tank that you build in your backyard, and you have to make these decisions at certain points about it. And that's kind of just to help break down with this code book. Because I know it sounds crazy right at this moment, but it'll make sense here in a minute. So we decide, okay, we're going to build the tank out of steel. Steel, what kind of steel? Stainless steel, steel less than 1/8 of an inch thick, steel at 1/4 inch thick or greater, 1/8 inch thick or greater. What kind of steel? That lets you know whether this code applies or not. So zoom in a little bit. So 1.1, this code contains requirements for fabrication and erecting welded steel structures. When this code is stipulated in the contract document, performance with all provisions of this code shall be required, except for those provisions by an engineer. Meaning the engineer can say, no, you don't have to follow. No, leave that alone. No, the engineer can do that. Okay? Or the contract documents, meaning the contract documents say, no, we don't want you to follow this or that. They can actually exclude and exempt certain portions of the code, which they never do. They always say, shall follow, or in accordance with AWS D11. As soon as they say that, they invoke this whole book. As soon as they say that in any contract document or whatever, any job, anything you guys may be building somewhere. 1.2 says limitations. If you want to scroll that and bring it a little bit bigger. So limitations of the code. This code is specifically developed for welded steel structures that utilize carbon or low alloy steels that are an 1/8 inch or thicker, with the minimum specification yield strength of 100 KSI. So what this means is, if I'm welding steel and it's a 16 inch thick, does this code apply? No.
Nope.
So 1/8 inch or greater. 1/8 inch or greater. So D11 only applies to mild or carbon steel, low alloy steels that are 1/8 inch or greater. So I know, okay, we're going to build a tank in the backyard. It's going to be at least 1/8 inch. We might use some 1/4 inch, some 3/8 here and there on certain things. So we know we can use D11 for this, okay? So now we have this thought, idea. We know, okay, this is what we're going to do. So it takes us to the next clause. So the clause 2, and before you go there, Missy, what would be the next logical step after we say, okay, yep, we're not going to build that thing out of plastic, we're going to build it out of steel. And it's going to be an 1/8 inch thick or a thicker steel. All right, now we have this thought and idea. What's the next thing that we would do? Anybody want to guess besides Daquan or Missy? Sharon? What would be the next thing we would have to do?
I don't know. You got me.
We're going to build a tank in your backyard. What do we need to do? We're
Blueprint?
building a tank in the backyard. Huh?
Blueprint?
Right, drawing. So we need to design this thing. Go to the next thing. So now we need to figure out how big is thing, where we're going to put it at. You got what I'm saying? How much water we need to hold? Okay, it needs to hold 2,000 gallons. Well, that needs to be a big tank. Or it needs to hold 100 gallons. Well, it's a smaller tank, but we design it. We draw it out. So design, and this, mind you, this book is all related to welds, right? So designing of the weld connection. So we're going to design the thing, and we're going to put all of this little welded connections in there. And this is where the engineers primarily live, in this clause, because it's all related to welded connection and welding engineering. all the different calculations, load calculations, all kinds of stuff is in this clause. Okay. We know we're building it out of steel. We have the design package drawings, the drawing package, so we'll call them blueprints because that's a very non-technical term. I know a lot of people use it, and it's like nails on chalkboard, it's out here. So we use the drawing, and we have the drawing package created, ready to go. What do we need to do now, Gary? What do we do?
List the materials.
Correct. Exactly. We need to order our shit. What are we going to build it out of? So go to clause 3. And it's a little bit confusing, but I'm going to explain what this is. So go to clause 3 and say page 45 at the bottom. We have page 6 right now at the bottom. There it is. Clause 3. Pre-qualified or WPS. So this is your material. This is what's pre-qualified. This is what's known that works. This is your 836s and all your other materials that are known that works. So we're going to order the material. What kind of material we're going to build this out of? We're going to build it all out of 836. Well, that's what happens in this clause. You go into your different design. Missy, scroll to page 49 at the bottom. And it tells you the list of materials and tells you why. So these are all your pre-qualified materials. This is how we know what to order. We've already decided with size and all that in the design, but now we know exactly what kind of material to order in those sizes. Okay? So now we get all our material. All right, we know we're going to put our tank there. We know it's built out of steel. We have our design package, our drawing package ready. We have a pile of cut steel material sitting out there ready to go. What do we need to do next?
Mm-hmm.
What do we need to do next? Got a bunch of materials sitting out there, got drawings. We got a rod, we got everything. What do we do now?
Get workers.
Hire some welders. Hire some welders. Go to the next clause, page 109 at the bottom there, Missy. Yeah, you can leave that big. That's good. Page 109. She's moving now. Look at her go.
I can see now.
I can see too. Hire welders. We have to test them all. We get them qualified. This is the clause about testing your welders. If you have specialized material that's not listed in your pre-qualified section, this is the area also where you qualify the materials. You qualify the welders. So they don't come qualified, they come pre-qualified. You got to qualify your welders and you qualify whatever material that doesn't meet this. So you have some kind of special material, hey, we're gonna make the spigot out of gold. Sorry guys. Hope I didn't lose you. I got a call. That never happens, right? You guys hear me still?
Yeah.
Mm-hmm.
Okay, well, you guys can hear me. That's all that matters. All right, we pre-qualify that material. We're going to make it out of 9 chrome or something special or Inconel, whatever, certain pieces. We have to qualify that material because it doesn't meet the pre-qualified aspect. If we're going to TIG anything, we have to, that's not pre-qualified. We have to qualify those procedures. And that material. The welders, we need to test the welders as well. If it's running thick, that's fine. They have to meet these criteria. That's all in this clause. So this is our hire welder section. This is, if you think so, a CWI is going to live between here, from clause 3 all the way through, and I'll explain to you why even more and more here in a few minutes. So, all right. So we got we know we're building the tank. We know where it's going. We have the drawing package. We have all our material purchased and staged. We hired a bunch of welders. They're all standing around shooting shit. What's next?
to weld specifications?
We made the weld specifications and all that, right? That was kind of that was pre-qualification when we order material and in the design. We test the welders to those weld specifications, the WPSs. So we got a bunch of welders that are tested, qualified, got the material sitting there, and they're all sitting around shooting shit. What's next? What do we do?
You need them to fit it?
What's that?
Fit it?
What was the question? Tell them to get their asses to work to build my tank. Right? Get to work, build my tank. That's clause 5. Clause 5 is get to work, build my tank. Fabrication. Okay? Anything related to fabrication in the field is in this clause. Anything and everything related to fabricating that structure is in this clause. It's the actual physical work of fabricating. Go to page 169 and then zoom in towards the bottom of it. See welding environment. That's going to roll over to 170. Talks about backing. Talks about the welding equipment itself. Talks about the welding environment. Talks about the welding and cutting equipment. You can see in 5.10. 5.11 talks about the welding environment. Talks about the temperatures that are allowed outside. Can you guys see that there at the bottom there? Talks about flux core. So let's yeah. So you're basically if you're welding GMAW, GTAW, FCAW, and EGW shall not be done in a draft or wind. To not be done in a draft or wind unless weld is protected by a shelter. Such shelter shall be of material or shape appropriate to reduce wind velocity in the vicinity of the weld with a maximum of 5 miles an hour. To a maximum of 5 miles an hour. Meaning, you're welding outside, and there's more than 5 miles an hour worth of wind, I'm shutting you down. If you're using any one of these processes. So if you're using any semi-automatic and automatic process and then your manual process, GKW, I'm shutting you down. If you're using gas, a gas shield, I'm shutting you down. Unless you put up a hooch or some wind blinds or something to slow it. Even if it's swirling around inside of there and it's more than 5 miles an hour, it does not meet code. And I can stop work right now. Until you guys comply. Comply. Obviously, I don't do that because that would make me like the biggest asshole ever on some of these jobs. But I do that with guys, you know better than that. If you get a bunch of porosity, I'm going to make you cut it out. So make sure you turn your gas up or do what you got to do to make it happen. But that's the difference between having a welder that's a CWI or an inspector versus somebody that went through inspection school like, oh my God, no, you can't do that. It's 5 miles. You know, they won't know. Just to guys give you an idea of that. Okay. Drawing package, material ordered, welders are working. Welders are done working for the most part. What's next? What do we do next?
Inspect.
What happens next? Inspection. Clause 6. You guys are seeing this now. It's in a logical order.
Mm-hmm.
It's not, just because I'm explaining this way, it's not as scary anymore. It's in a logical order. This is all your inspection criteria, different things from inspection. Doing your VTs, your MTs, your PTs, your RTs, all that in this clause. Okay? The CWI primarily lives in clause, well, pretty much all of it, but primarily lives in clause 3 through 6, primarily. So there's all types of stuff in here. Table 6.1 is in here. Remember we were looking at table 6.1? If you scroll to 6.9, and that's on page 193. Let me show you. Remember table 6.1 referred to, it says 6.9? I'm going to show you guys how crazy this is. This book, man, it's crazy. Zoom in on that little thing, like Jesus wept. It's like it's that small. 6.9. Guess what? All welds shall be inspected and shall be acceptable if criteria, blah, 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 blah. Are you serious? See table 6.1. 6.1 says go see 6.9. 6.9 says go see table 6.1. Are you kidding me? It says the same thing. However, this is where the inspector makes their money. This clause makes sure that Daquan's getting paid. This clause, this little clause right here is the reason why he's out there in that job right now. All welds shall be visually inspected. All of them. Attack of the weld as well, by the way. All welds. If they're following this code, all welds shall be visually inspected. Okay? Next clause, clause 7, is page 245 missing. You scroll out and jump to 245. I won't call it an oddball. It actually makes sense, but it makes sense if you have the experience. So generally, when you weld something, we build our tank. We're going to decide whether we want to insulate this thing or whatever the case is. So if we're going to put insulation on this thing, we have to do something called stud welding. COVID-19 emails, great. We'll do something what's called stud welding, and that holds insulation on. So clause 7, or if we're doing the decking, which Daquan has done a lot of inspection, stud welding inspection on decking. They're doing studs. They're going to pour concrete. They'll have studs there as well. This is generally done after the structure is built. That's why it's in this order. So you do your inspection on your structure, then you go to stud welding, and this is almost a book in itself. This it's small. It's clause 7 small, but it could be a complete code book itself because it goes from general requirements all the way through the material, all the way through the qualification of the welds, qualification of the welder, the inspection criteria for it. It's almost a standalone code book, but they didn't want to issue a code book for it, so they decided to throw it in here. All right. Yay, we got our tank built. Everything's Gucci. Things are going fine. Everything's done under budget. Great. This tank works great for our homes and our little community that's using it. And this tank is now 20 years old. Starting to leak a little bit. Got this over here sagging. That welder did okay, but those welds kind of broke loose. What do we do?
Maintenance.
We got to repair it. Right, correct. So clause 8. Strengthen and repair this thing. Okay? Clause 8 is 1 page. Well, page and a half, I should say. No, it's 1 page. That's it. 1 page. It's literally clause 8 is 1 page. In D1, and in 2015, they added clause 9, which is tubular structures. You want to go to jump back to clause 9. So they added this. They added 3 more clauses to the new 2020. We'll go over that later. But I just wanted to give you guys an idea of how to understand this book. The rest of the book, I don't know if you guys can see this. You guys see this book? So this is clause 9. So this is clause 1 through 9, including the front part of the index or whatever you want to call it. The rest of the book is commentation, all commentary, and an index in the back. So your code test, if you ever take one, a CWI test, or you're working as an inspector, even as the SMCTC1A VT level 2, using the D11, it's right here. And you're primarily going to live between clause 3 and 6. So 3, 4, 5, and 6 is where you're going to live at. Very simple. So this big old book's not that scary anymore, is it? Can't wait to get your hands on one. We'll get some sent out to your instructors where you guys could use it. Go from there. Okay.
Mm-hmm.
You guys find this useful?
Yeah.
Good. Thank you.
Yeah,
Kelly,
absolutely.
Yep. Thank you. Kelly, you're an experienced welder, so did you find this useful?
Yeah, actually I did.
Good. So can you tell us a little bit about you? And I don't think everybody knows who you are. They kind of know who each other are, but nobody really knows who Kelly Logan is. Tell us about. She's very special, by the way. So tell us about Kelly Logan.
I went to LTI. I graduated in 2015, and I passed all my certifications. I was the first one in LTI to pass my 6G, and I work at Miller Industries now. I'm actually an inspector, and I also fix whatever is messed up. So, but that's what I do.
Very good. So 2015, and 5 years later, she's an inspector at Miller. and she could probably, it'll probably something with me for some time, whatever. She probably can go pass the CWI test pretty soon. You feel confident that you can pass one, Kelly?
Oh yeah.
Yeah. So it doesn't take a lot to get from full-out welding to inspection, and there's a huge need for people with a high level of integrity to get into the inspection field. So there's a lot of things that we're going to go over with these sessions. Missy's going to try to organize. She's going to probably yell at me when we get off with you guys, like, you're all over the place. Yeah, I was. Oh, well. There's tons of information. I'm obviously, we're all very passionate about this, about you guys' success and us being a part of that. We're all just kind of shut in from this COVID-19 stuff. It's depressing. There's some hopeful news that's coming out today, it looks like, but you guys stay safe. And call me and text me for anything you guys need. I don't care what it is. Just want somebody to talk to. If you want to see me weld, give me a call later. I'll call Daquan, or I'll go in my garage, put on my hood, and I'll start welding. You guys are close to me. I'll be like sneaking you over my house in the garage. We're here, weld this, weld that. Let's do this, let's do that. And I'll be teaching you drawings and all kind of crazy stuff. But I obviously can't keep you guys in front of this computer screen all day. So, any questions for me?
No.
No. Are we just going to be trying to do this like once a week, man?
I'm not sure. I'll talk to Missy about it, but just whatever the case is, we're going to have to do it because I gave so much information, dude. We have somebody new join. They're not going to be able to keep up. You know what I mean? So we're going to have to I don't know. Yeah, definitely once a week, but I don't know how it's going to look. We're going to need some level organization to the thing. Okay? And it's going to add, so some of these going to get a little redundant as we talk to new people get on it, because there's a lot of valuable information. But go from there, okay? Daquan's actually in talking to the client right now. He's in the client's office. Look at him go. All right. Thank you, guys.
Thank you.
Thank you.
All right, I'll get some more information out to you guys
Thank
once
you,
we
guys.
figure out what exactly we're doing for the next ones.
All right.
Table 6.1, definitely
Okay.
want to screenshot that and send that out, if nothing else, okay?
Yep.
All right. Thank you, guys.
Thanks.
Bye-bye.
Bye.
All right,
you.
thank you guys.